Good evening, everybody. Today I want to teach you how to use the Pythagorean theorem to find the length of a right triangle's hypotenuse. A lot going on in that title. Make it the next one in your math notebook where you've got a free page. After you've done that, mark that page, close it up, turn off and clear out any distractions. Get your mind on maximum, and off we'll go. Start with some vocab here, Pythagorean theorem. We talked about that yesterday, so that sounds difficult, can be tough to remember. And another vocabulary word here that we're going to get to have to know a bit too, not as bad as it looks. So let's start with that, some vocab. So first, yesterday we did an activity where we looked at this clever way to find the side of a triangle that's not attached to the right angle. It has to be a right triangle. And it was always this side that's not coming from the right angle. So triangles, right triangles in particular, have what we call two legs and a hypotenuse. So those things we dealt with yesterday and didn't give a name, we're going to give a name today. So the legs are the two sides that we would call the legs. It all has to do with the right angle. So they're the two sides from the right angle. And then the other side that is across from the right angle, we would call it opposite of from the right angle in geometry, is called the hypotenuse. So that's all that is a fancy word for meaning the side of the right triangle that's not part of the right angle. And that's it. So leg, hypotenuse. And so yesterday our idea was if you square the legs, we didn't call them legs yesterday, but if you square the legs, squared is 9. I'll put a little 2 like squared. 3 squared is 9. So if you square the legs and add them up, so those together make 18, that's the square of the hypotenuse. So it doesn't mean that 18 is the hypotenuse, it means 18 is the square of the hypotenuse. So to find the actual hypotenuse, we use the square root. I have a calculator up and I don't. And then we got it. So if we just look up now, you can't see it, can you? Put it over here. Square root of 18 is about 4 1/4. That is about how long that was. That was our idea from yesterday. So square the legs, you'll get the square of the hypotenuse, and you can go back and get that. So 3, 3, and a bit more than 4. I want to put some mathy language to it today. So yesterday we kind of used the idea. I'm not going to teach you anything new today, but I am going to make it more formal. We're going to make it more mathy. So now that we've got this vocabulary, here's what it really says. It says, remember we talked about if you square the legs, they make the square of the hypotenuse. So we would say the first leg squared plus the second leg squared equals the hypotenuse squared, so to speak. This squared plus this squared equals this squared. That's the relationship between the two legs and the triangle. We didn't make it look super mathy yesterday, but that's what it is. Now, it's actually even more formal than that usually, because you're not going to usually see the Pythagorean theorem written with the words leg and hypotenuse. You're going to see it with variables. And so it ends up looking like this. Usually math people represent it in a mathier way. They name the legs specifically A and B, and they name the hypotenuse specifically C. So you'll see the Pythagorean theorem usually written A squared plus B squared equals C squared, which makes it look really advanced, right? There's 3 letters in it, 3 variables in it. Makes it look very tough. But it's not different than what we did yesterday. A and B are always the legs, and C is always the hypotenuse. That's just the language for it. But this is the way you usually see it, and that can look more difficult than it is. This is really just the formula for what we learned yesterday. Yesterday we dealt with it casually. This is the formula. So that's what you're going to see. So let's do an example. So we want to find this hypotenuse of this right triangle. So notice 40 is touching the right angle, 9 is touching the right angle, so those are legs. And remember, in a right triangle, we're usually going to call the legs A and B. It doesn't matter which is which. You can do A, this one B. And then the hypotenuse, we usually call C. We just do. So 2 methods of figuring out this missing side, right? First, if whatever you did yesterday, you practiced and it was working for you, I don't want to take that away from you. You know, if you kind of like made up your own way that predictably got you the right answer, do it. It's still okay. I want to show you the very formal looking way to do it that you'll often see done with the Pythagorean theorem, right? So what we would do, we would say formally, the theorem says that this leg A plus this leg B, both squared, equals whatever the hypotenuse is, also squared. So you're usually going to typically see it with the formula written out, and then we're going to use substitution. Remember that word from back in algebra earlier in the year, substitution, to plug in the ones we know. We know A, and we know B. So then you would see a next step. So A squared is really 9 squared. B squared is really 40 squared. And C is the one we don't know. Right? So that's just substitution. I knew A and I knew B, and so I just put them in. Next step would be to do the math we can do. I can do 9 squared. So 9 times 9, I should have known that one. That's 81. 40 squared. I have a squared button, sorry. 40 squared is 1600. C squared I don't know. That's what I'm looking for. Remember, C is the hypotenuse. Can add those together. 1681 equals C squared. It's easy to get here and think you're done. And be like, found it. It's 1681. It's not. Remember, C squared is 1681, not C. We want to know C to actually find it. The formula you have to deal with C squared, but we want to know C. So the inverse operation now, C squared is 1681. The inverse operation of squaring, as we learned before, is square root. And so C is going to be whatever the square root of 1681 is, which I don't know. That. 41. Oh, look at that. It's very rarely an integer. It's usually going to be a irrational number. So now I know that's it. So this one is 41. So in this particular triangle, the hypotenuse is 41. And that makes sense. It looks only to be slightly longer than that leg anyway. So if your method yesterday worked, that's cool. I do want you to start to get used to the formal way so that when you see problems that are sort of like, what did this person do wrong or something like that, you recognize this work. Okay, alert, before we get to your we do, remember the Pythagorean theorem, or just call it the PT, only works for right triangles. That's it. So like this is not a right triangle, so I cannot use the formula to find this missing side. No right angle in the triangle. There is a way to do this for other triangles, but you need complicated and obnoxious ratios that you're going to learn in geometry or trigonometry a lot later. So this formula I'm teaching you, this Pythagorean theorem, only right triangles. All right, open your math notebook up. 3 quick things to write. So first, let's get some vocab down. I'd love for you to pause now, copy this, and then we need to do, I want to write it for you first with the words that are easier to understand. Then we'll do the ABC business. So pause here, copy this. So the Pythagorean theorem says, in a right triangle, and only in a right triangle, the leg squared plus the other leg squared equals the hypotenuse squared. This is how I think of it. I don't like that ABC business. I think it's complicated. This is what we need. Leg squared plus leg squared equals hypotenuse. And if you need to write these new vocabulary words down, a leg is a side that touches the right angle, let's say. And the hypotenuse is the side across from the right angle. Doesn't touch it. And those are important vocabulary words to know. They'll come up a lot. So that's the first way to think about the Pythagorean theorem, is with this formula. This is in my mind, this is what I think. But mathy people represent it in a mathier way. If you can just keep your same diagram here if you want, and add in maybe in a color or something. Math people are usually going to make the legs be A and B, and the hypotenuse be C. So in this one here, just so I have more room, that's what they did. Leg A, leg B, hypotenuse C. So the Pythagorean theorem in a mathier way is usually written as A squared plus B squared equals C squared, where A is a leg, B is a leg, and C is a hypotenuse. So you're usually going to see it this way. This is like the official Pythagorean theorem. Everyone who's ever learned math has seen this before. A squared plus B squared equals C squared. So that's the theorem, so to speak. So let's apply it. Quick example for when you want to copy and write. I want to make sure you remember, whatever you figured out yesterday when we did this without much training, this is okay. I don't want to make you follow new steps if your old steps are working for you reliably. Totally great. I do at least want you to see how it usually looks when somebody applies the Pythagorean theorem formally, right? So remember, this will be a leg, this will be a leg, and this will be a hypotenuse. And we usually call the legs A and B, and the hypotenuse C. So the official theorem is A squared plus B squared equals C squared. And again, that looks super complicated because there's 3 variables in it. But you know 2 of them. So that's the next step, is to use substitution. You actually know A and B so in these cases, right? You know A, you know B, you don't know C, so we leave that one. That's the variable we're trying to solve for. Nothing to do before we simplify this left side. So 11 squared is 121. 3 squared is 9. So now those add up to C squared. Add those up. 130 is going to be C squared. Now, important, I'm going to make a note, not done. This is an easy place to think you're done. Like, oh, got it, 130, done. That side is not 130. That is way too big. It's not 11, 3, and 130. That's more than 11, but it's not going to be 130. So you're not done quite yet. The last step is that's not C, that's C squared. So to find C, the inverse operation of squaring is square root. So C is going to be the square root of 130, not 130. And that's going to be that, about 11.4. So I'll put the about sign there, the about sign here, and that's what we end up with. So that's what the work usually looks like if you want to use the Pythagorean theorem. Write the formula, fill in what you know, add them up, find the square root. That's what it looks like. Okay? Maybe worth putting in the alert. You don't need to necessarily draw it, but this is important. This only works for right triangles. The Pythagorean theorem is only true for right triangles. We cannot do the A squared, B squared, C squared for other ones. Other triangles, we don't even use the words leg or hypotenuse. Totally different thing. So that's it. Y'all, I hope this makes some good sense. I hope you were off to a good start yesterday, and I hope this makes you feel like you understand the more formal version of the math today. Once you feel like you do, you are all set, and I'll see you tomorrow.